Greetings, calculus scholars. This is Mr. Benzel here on day one of this e-learning day. And I would like to spend this day going over the concept of what this integral symbol means geometrically and kind of look at our typical geometry problems related to Riemann sums and integration so we can get some really good quality review on those, and you can be armed with the concept of what an integral is. So all the time when people kind of see these type of questions, they see, this is how they kind of react. They say, calculus, symbol, Greek, hard. We don't want that experience for you, so we want to kind of do this the right way and think about what those symbols mean. So we'll get back to the top on this problem and kind of brainstorm how to solve this problem. So let's actually start at the end here. This says, find the integral from 0 to 9 of g of x dx. And it really ties into the essential question, how can you take the areas of shapes that are curvy or do not have the textbook geometry formulas? So what the integral symbol really means, we get a pencil here, is the area under the curve or between the curve and the x-axis. So, one question that we may want to think about here is, how would a geometry student kind of interpret this type of problem? Like if I asked one of my geometry scholars how to take the area of these shapes, they could do it. So, for instance, they could look at the blue region here, and they could see that it's a semicircle. So I'm going to call this, I'm going to not shy away from calculus notation. Remember, when we have a limit of integration, we're thinking about starting at 0 for integrating, and we're taking the area around the curve, under the curve, until we get to x equals 4. And that is g of x dx. So, let's actually tell this what this is geometrically. So what this is geometrically is it's just a half a circle. And remember, the formula for a circle is pi r squared. And we can actually see here that the radius of the circle, r, is equal to 2. And we are okay, keeping your answer in terms of pi. So this is not a, put the answer to the 100th or something like that, but we're looking for, do you know the geometric concept of what an integral is? And can you express your answer, in a professional way? But if we're kind of doing the half times 2 squared, so that's half of 4, we get that that is equal to 2 pi. And then I'm going to use red for the second integral. And this, when we represent it as an integral, we are going from 4, x equals 4, all the way to x equals 9. and function's called g of x del dx. And we can actually look at the geometric features of this triangle and see that the height is equal to 3 and that the base is equal to 5. And we see that the area is 1/2 times 3 times 5. Or in other words, 7.5 units. Okay. So let's look at the questions and what they're asking. First question, integral from 0 to 4 of g of x. Well, here's the good news. We already computed that just by using the simple concept of geometry. So we got that area was 2 pi. Oh, and guess what? We also got the integral from 4 to 9 of g of x. So we took 3 for the height, 5 for the base, and multiplied by 1/2 to get 7.5. We'll just be consistent here and use red to let us know that we used a red area. And finally, it asks us for the integral from 0 to 9 of g of x dx. Well, here's the good news. We know the integral from 0 to 4, and then we know the integral from 4 to 9 as well. And this is kind of a logical property of integrals here. So this says that the integral from 0 to 9 is the same thing as adding the integral from 0 to 4, g of x dx, plus the integral from 4 to 9, g of x dx. And lo and behold, we already got those answers. So let's see, we got 2 pi. And we got 7.5. So at the end of the day, the integral symbol, it incites a lot of unnecessary panic, but it's really just a compact framing of taking very set geometric areas. So in this problem, we have some very set geometric areas like half a circle, half, maybe a triangle, and we add those together, and we have our final answer. So this is kind of the geometric interpretations of integration. Next video, we will be looking at the different types of Riemann sums and best practices in creating the Riemann sum computations. Please continue to enjoy